one thing that's important to point out is that what's happening so far with SpaceX and NASA is a partnership. So it's portrayed a lot in the media as this is a private company doing things on its own, and they're not, that NASA is not involved, and they've kind of turned it over to SpaceX. But quite the opposite is true. It's a partnership, and it's not that different from the way that NASA partnered in the past with Lockheed Martin and Northrop Grumman and Boeing and Rocketdyne and Rockwell when they built the space shuttle. When they built the Saturn V rocket that went to the moon, it's not like NASA had it's a NASA factory full of government employees that built with the hammers the Saturn V. A part of a version of the Saturn rocket was built by the Chrysler Corporation, the car company. So NASA's been working with private companies for a long time. What's happening now is actually much more subtle, the difference, and it's a shift in the relationship in the partnership between NASA, the government, and the private contractor. When NASA has stepped back and given the private contractor, SpaceX, or Sierra Nevada, or Boeing, or Northrop Grumman with the Cygnus rocket, these private companies have been given a little bit more latitude to innovate, to make the decisions about what to do. So NASA still says we need a rocket that can do all these things, okay? But you figure out how to accomplish it all. We're not going to tell you exactly how to build the rocket. In fact, we won't even tell you if the spaceship is going to be a capsule or if it should have wings. You figured that out. But we need it to carry 4 people, and we need it to go to the space station. So NASA is still setting out the requirements, but giving wiggle room to these private companies to do things in a new way. And that is different. The other thing that's different about it is the way the contracts are scheduled or paid. Instead of a cost-plus contracting system, it's a milestone-based system. So if you achieve a certain goal, you get paid. If you don't achieve the goal, you don't get paid. So the risk goes away from the taxpayer and onto the shoulders of the private company. But in return, the private company gets to own the product. So if they want to use the rocket and the capsule, to send private citizens up into space and make money by doing private missions, they can. Rockwell could not make another space shuttle and sell tickets to ride on the space shuttle. That was impossible. It was illegal. But SpaceX can, and Boeing can. So that's a subtle difference. It's not. So that's why I could talk for hours about this, because I think it's not exactly what you've seen. Now, this has been extremely effective. Okay, we were able to do the commercial crew program for, I think, a grand total, including both contracts, of about $5 billion to get 2 rockets, 2 spacecraft, 2 launch pads, 2 mission controls, from scratch up through the first almost 10 years of flights. We've spent $50 billion on SLS and Orion, which hasn't yet flown at all, okay? So the cost, it's not a little bit unfair. On one hand, the SLS is a much bigger rocket. It can go further. But on the other hand, you have 2 rockets and 2 spacecraft. So it's I don't know if it's that fair of a comparison, but it is true that it has cost NASA a lot less money. The U.S. taxpayers have had to pay a lot less money to do it in this way. And NASA sees the effectiveness of this model. And they are repeating it for part of the Artemis program, for the ship that takes the astronauts from the orbit around the moon down to the lunar surface. They did it the exact same way, and SpaceX won that contract called the Human Landing System. And I think we'll see more and more of that, not only at NASA, but also hopefully at the Department of Defense. And I think there's a lot of this model, I think, has been successful. It's been very, very good for the U.S. taxpayer. And I'd like to see it continue as we go further. As far as the space debris goes, it is a big problem, and it is getting worse. And low Earth orbit is full of debris, and it's making it more and more dangerous to spend time there. The worst debris has come when we have done these tests of anti-satellite weapons. So the best thing we can do to stop the debris from getting worse is stop shooting things in space. It's stupid, all right? We need to stop that because it's making it dangerous for everybody. It's making it dangerous for American astronauts, for European astronauts, for Russian cosmonauts, for Chinese taikonauts. It's making it dangerous for everybody. So please stop. If you're listening, stop shooting things in space. That's, for the best thing we can do. The second question about climate change. It is true that a lot of the rockets that we launch, not everyone, but a lot of the rockets we launch do produce are fossil fuels. So the Falcon 9 is RP1, which is basically like kerosene and liquid oxygen. There are other rockets, however, like the core stage of the SLS, that use hydrogen. And so they actually don't produce any carbon, the core stage anyway, doesn't produce any greenhouse gases. It really just produces water. Although water vapor is a greenhouse gas, but it doesn't persist. So anyway, the point is it depends on the fuel. But the problem is we are kind of stuck with the fuels that we have right now, because up until this point, nobody has invented a better, more efficient, and more practical way of getting off the surface of the Earth than liquid rockets. And so we're kind of stuck with that. However, if you look even at the rate we're launching now, and even if you project out into the future, the percentage of overall greenhouse gas emissions that come from these rocket launches is so tiny compared to all the other sources of emissions. When you look at automobiles, when you look at fossil fuel burning power producing plants, when you look at cows and other livestock, the amount that rockets produce, even compared to aviation, when you compare it to all the airliners out there, it's still tiny. Even if we launch many, many more rockets, we have other areas that we need to attack first to address climate change. And if we had an alternative, I would love for us to be able to use it for rockets. It's just a really tricky thing to do right now. Well, first of all, the process we've used to date to select astronauts is obviously flawed and imperfect, because I managed to get through. And that I still don't know. People ask me how, why, you, and I still have no good answer. But I can tell you, because when I got there, I ended up sitting on the other side of the table when I did the interviews. And I can tell you that what we're looking for is somebody who is very successful in a related field. So somebody, we all did something before we were astronauts. Either they were really good test pilots, or really good engineers, or really good scientists, really good doctors, and had a lot of success. And once you see that, and there are a lot of people that meet that criteria and have resumes that are very impressive, then once you reach the final stage, you're no longer really looking at the resume, but you're really asking is, do I want to go camping with this person? Do I want to share, maybe be roommates with this person? That's really is much more of a subjective, interpersonal question, and it became even more important when we started doing long duration missions on the space station. On a shuttle, we would go for 1 or 2 weeks. And no matter how bad and hard it is to get along with somebody, to do something as remarkable as flying in space, you could deal with it for a week or two, even if they're really not nice, right? But for months, for a year, that is much more difficult. So the longer the duration, the more critical it becomes to select people who can function in that environment and are not going to become toxic to the operation of the crew. And that involves a different type of process of selection. As we look to go to Mars, and now we're talking about multiple years, okay? And the people that settle on Mars hopefully colonize Mars. Now you're talking about a lifetime together. But the problem is, if we're talking about sending a small number of people on a government mission, like NASA astronauts to plant the flag, like we did on the moon, then yes, we probably will pay close attention to these things. But if you're talking about a commercial mission, if you're going to be selling tickets and trying to transport large numbers, tens, hundreds, maybe thousands, maybe tens of thousands, someday maybe hundreds of thousands, millions of people to Mars, you can't screen them. It's going to be a question of, if you buy the ticket, you go. And you don't have to pass maybe a basic examination to make sure you're not completely crazy. But it's going to be more difficult. I think there's competing pressures in the future. On one hand, for longer missions, you want to screen more carefully. On the other hand, if we're going to fund it by having people pay for their ticket, you want to open it up to as many customers as you can.